So now let's look at the leading coefficient test, and let's consider that function that we were discussing. H of x equals 3x to the third minus 2x plus 6. As long as your function is in descending order, the leading coefficient is going to be the one that's leading. So that's why it's called the leading coefficient. You'll see me abbreviate this as LC is 3. And the important point here is that the leading coefficient is positive. Now, for instance, if for some reason your function was not in descending order, you need to understand that your leading coefficient is always the coefficient in front of the highest power, or the highest degree. Now, the other thing to note is the polynomial has a degree of 3. And so your degree is odd, the highest degree. So that's going to be important. If you think about even your parent functions, so for instance, let's just take f of x equals x to the third. This is your parent function. The leading coefficient is 1, which is positive. If you think about what that graph looks like, we can talk about the end behavior. And when we say what is the end behavior, it's the behavior on the ends of the graph, okay? So how does the end or the ends of the graph behave? Well, for instance, f of x equals x to the third. I'll draw that graph up here. The right is rising. The left is falling. Well, if you type in g of x equals x to the fifth, and you could add some, let's say x to the fifth minus 4x to the third plus 7. Well, the leading coefficient here is a positive 1. It's going to follow that same pattern. It's going to rise to the right, and it's going to fall to the left. Okay, well then let's think about another parent function that's different. Let's think about w of x equals x squared. So this is your basic parabola. So notice the leading coefficient is positive. So leading coefficient is positive. And the degree is even. Well, think about what that graph looks like. You know what a x squared graph looks like. Notice the end behavior, okay? The end behavior on the left, it's rising, and on the right, it rises. Well, you could plug in something like g of x equals 3x to the fourth minus 5. The leading coefficient is positive. So the leading coefficient is positive, and the degree is even. It's going to follow the same pattern. The end behaviors, both the left and the right, are going to be rising because that leading coefficient is positive. And we're going to be able to make generalizations based on that end behavior.